Hello, I welcome you all in this presentation related with the subject fundamentals of manufacturing processes. So, here today we will talk about the fundamental approaches used in or used in manufacturing. We know that the manufacturing is used for making the goods, products which can be used by the human being, and for that purpose it is necessary that they are produced of the desired size and shape, they are produced with the desired finish, and close control of the tolerance, and here with the desired properties. So, these are the three aspects: desired properties or characteristics. So, for realizing the desired size and shape, desired finish and close control over the tolerance and desired properties, it is required that a wide range of the processes are used. So, the processes which are used in the manufacturing are very wide in range, they are very different in nature, but there are some of the basic approaches are used which helps to achieve the desired size and shape. Then there are certain other processes which are used for achieving the desired control over the dimensions and the surface finish, and another set of the processes which are used for achieving the desired properties and characteristics in the product being made, so that the goods and the products being made can perform the desired function. So, these processes actually can be grouped in certain categories. These categories are like this: the processes which are used for primary forming or shaping. So, the measure, shape and size is achieved through this category of the processes. Under this category of the means, this kind of the objective is achieved through certain processes like the casting and deformation based processes like rolling, extrusion, forging, etc. And there is another one which is powder metallurgy. This is another route which helps us to achieve the desired size and shape, but it uses the powders as a raw material in primary forming processes. Then we have the joining processes. When the shape is complex and it is not economically viable to make the product using the primary forming processes, then what is done, the simpler shapes are brought together by joining, so that the desired size and shape can be achieved. And for this purpose we use the welding, brazing, soldering and even adhesive joining. These are this in under this category the simpler shapes are brought together, so that the desired size and shape is achieved. Then we have the material removal processes. Material removal processes. In this category, the unwanted material from the undesired material or unwanted material from the raw or stock material is removed to get the desired size and shape. So, that material is removed from the raw material to get the desired size and shape. In this category, primarily there is metal cutting, and then we can say grinding. All the close control over the dimensions as well as finishes achieved through the grinding. And in the under the material removal category, there are two broad groups. One is conventional machining processes. Conventional machining, where the material is removed at macro scale, like in your turning on the lathe or the milling on the milling machine, shaping. These are the conventional machining processes which are used for the materials having the moderate properties. But if it is about the exotic materials which are difficult to machine by the conventional metal removal processes, then you can say newer machining processes or unconventional machining processes are used, and they are based on the different approaches, like use of the heat, use of the impacts, use of spark, or use of the laser radiations, use of chemical interactions and chemical reactions. So, the various principles are used in unconventional machining processes to remove the undesired material from the stock or from the raw material, so that the desired size and shape and features can be produced. So, this is the category of the unwanted material removal processes. Here macro scale material is removed and very fine and little quantity of the material is removed in the grinding. And then we have in the metal cutting, there are two broad categories: conventional machining and unconventional machining. In conventional machining, like turning, milling, shaping, and on the unconventional machining processes, there are number of the newer machining processes which have been developed, like electric discharge machining, electrochemical machining, water jet machining, ultrasonic machining, abrasive finishing based processes, etc. So, those are the unconventional machining processes. Now, we have the another category wherein like semi finishing or finishing processes. In this category, very close control over the dimensions as well as the surface finish is achieved using processes like honing, lapping, polishing. These processes help to achieve the very good degree of the finish, like less than 0.1 micrometer or even the finer one in terms of the RA. So, then improving the properties of the material, and so for that we have the another two categories. So, the point, another point is improving the properties of material. There are two categories in this one, wherein the bulk material properties are modified. Entire the component properties of the entire component is modified for this purpose, like the heat treatment various types of the heat treatments are there, like annealing, normalizing, hardening and tempering, mar tempering or stampering for the steel's precipitation hardening, etc. So, that they will be helping us to improve the properties of the entire component or as a whole entire component, and there are certain methods which are used for improving the surface properties only, so that desired functionalities and prolonged life can be achieved. And in this category we have the case hardening process, wherein either just a structure is modified or the chemical composition near the surface layers is modified, so that the desired set of the properties near the surface can be achieved. There is another method wherein the coatings are applied at the surface, so that the desired properties can be achieved. So, we will try to talk about all these aspects in this subject, and in this presentation basically I will talk about the approaches which are used for these 5 categories. So, starting with the casting, which is a primary shaping or the forming process. In case of the casting, it's a very simple process, wherein the raw material is basically heated in crucible or in suitable furnace, then so that it can be brought to the molten state, and then this molten metal is poured into the mold. Mold is a cavity which is prepared either using the sand or the metallic mold, and this molten metal is poured into the cavity, so that this cavity is filled in. Subsequently on solidification of the molten metal, we get the desired solidified casting in this form. So, this is how we get the desired shape, but the product which is made by the casting is usually rough and not very close to the dimensions desired. So, roughness is high and the dimensions are not actually dimensions are not very close to the required ones. So, what is needed? We need further processing for achieving the desired finish and achieving the desired dimensions, and for this purpose mostly machining processes are used, grinding processes or the finishing processes are used, so that desired finish can be achieved. So, depending upon the function of the product made by the casting, the different degree of the control over the dimensions and the different surface roughness or surface finish is desired. So, this is what is there in the casting approach, but for this purpose what is needed? Your molten metal melting point of the metal to be processed must be low. That is why aluminum having like say 660 degree centigrade melting point, magnesium and cast irons. So, those having the cast iron having the low melting point, they are easy to melt and it is easy to process them to get the desired product through the casting route. In this case, the hardness, strength of the material does not play any role. What is important? It should not interact much with the gases and the atmospheric ambient air, which otherwise can lead to the formation of the inclusions, impurities or it can lead to the porosity in the cast products. So, this is one approach. This is good for the low melting point systems, and it is commonly used by the jewelers for making the jewelry. Similarly, it is extensively used for making the products of the plastics and products of the cast iron, products of the made of the aluminum, magnesium, even copper, like in form of brass and bronzes. So, those low melting point systems can be easily processed through the casting route. This is the primary forming or shaping process. Another is forming process. In forming is basically based on the deformation based approach. Deformation based approach. So, for achieving the deformation, obviously we need to apply the force. Mostly it is compressive force, but it can be of the bending type or tensile type also, but that is very not very common in the processes. Compressive force is normally applied. So, for achieving the deformation, we know that from the engineering stress strain diagram, what we know that like say for typical steel products, the plastic deformation sets in after the elastic limit, and so for causing the plastic deformation, it is necessary that the applied force develops the stresses which are greater than the yield strength of the material, so that the plastic deformation is realized. So, what is important, that material should have, it is good to for this process to get the desired size and shape by the deformation approach, is that the material has the low yield strength, so that you can deform it easily. So, that strength of the metal to be processed, if it is low, then it is good and easy to deform. And another one is elongation. Elongation or the ductility of the material is high. This is also, we can see low ductility metals, like they break like this, and if the material is of the high ductility, then it will be deforming a lot prior to the fracture. So, this is the strain at the fracture which is used to quantify the elongation, like say for the low carbon steels or very like say 0.1 or 0.05% carbon steel, this may be as high as 40 to 50%, but like say for the cast irons, it may be very low, maybe 2 to 3%. So, if the ductility is very limited, you cannot deform it much plastically, while if the ductility is high, the deformation is easier, and the percentage elongation is one of the very common criteria or the parameter to check the ductility of the material. So, for the deformation based approaches, it is necessary, it is good that the yield strength of the material is low and ductility is high. And to facilitate this, it works on the two approaches, like the deformation. There are two approaches of the deformation based processes. One is the cold deformation based approaches, and the hot, which is cold forming or hot forming. Hot forming, cold forming or cold deformation process or hot deformation based processes. So, and there is one more warm also, where depending upon the temperature. So, this is normally carried out under the ambient condition, and this is above the recrystallization temperature, above the recrystallization temperature. So, which is about 0.4 to 0.5 times of the melting point of the material in Kelvin, that is the recrystallization, 0.4 to 0.5 times of the melting point of the material in Kelvin, and this is under the ambient temperature conditions. While maybe warm forming is carried out at low, very below the recrystallization temperature and above the ambient temperature, maybe like 100 to 200 degree centigrade heating is carried out, say uh, for the steels, but certainly it is the below the recrystallization temperature of the material for the warm forming. So, when the hot forming is applied, temperature is high, and that helps in, so increase in temperature during the deformation or during the forming helps to reduce the yield strength of the material. At the same time, it helps to increase the percentage elongation. So, a combination of the a combination of both these characteristics means variation in both these properties, like reduction in yield strength and increase in ductility helps to deform the material under the effect of the external forces easily, so that the desired shape and size can be achieved easily. So, there are certain processes the rolling is one process wherein like there are two rolls like this, and the material is forced to pass through these rolls, so that its cross section can be reduced. So, here like say initially thickness is this much, and thereafter its thickness is reduced from the T1 to T2. So, basically the cross section size is reduced in this particular case in the rolling processes. Similarly, so here material is being basically forced to deform and take some other cross section, like say if earlier it was like this, then after the deformation the thickness will be reduced, and under the constant the width conditions, actually length increases, the width remains constant. So, here likewise there are various deformation based processes, that is what we can see from this diagram. Here this is the rolling process, where the stock is fed through the rollers, and under the effect of the compressive forces its cross section, its thickness is reduced. So, this is in this case the rotation, the movement of the stock is in one direction, and in this case it reverses, movement is in both the directions, so that every time there is a reduction in the thickness of the plates. This is another deformation based process, where within the constraint under the constraint conditions of this structure, the material is forced to pass through this die, so that the cross section is reduced from such a large size to the smaller size. This is the extrusion process, which is used for making the long cylinder shaped jobs of the uniform cross sectional area along the length. So, these are the formation or the deformation based processes. Then coming to the joining. In case of the joining, there are the processes like welding, soldering, and brazing. So, here what we do, since making the complex products in one go of such kind of the geometry is difficult. So, what is done, we take two simple shapes like this and another one like this, and the two are joined together by fusing the components partially along the so, this is how the joint is developed. So, otherwise it is not that easy to make such kind of the shape using the deformation based process. Of course, it can be done using the casting, but if the material is not favorable for the casting due to the thermal properties or due to its melting point and the way by which it responds to the heat. So, it is better that it is made in simple shapes and then they are joined together. So, this is the case when fusion is possible. If we find that no, even fusion is not possible, then in that case what we can do, we can apply just brazing alloy. So, we heat it up and then the components are heated. So, and then the brazing alloy is brazing material is applied or it is filled in at the interface, and on solidification it produces the joint. Similarly, for the shouldering is not used for the load carrying joints, it is mainly used for making the electrical connections, so that desired connectivity between the components being joined can be achieved. So, in the case of the joining, it is like the simpler shapes are brought together, so that the desired size and shape can be achieved. Like the ship structures, ships are very lengthy, very heavy in structures. So, they cannot be made by any of the conventional processes like forming or casting. The simpler shapes, simple plates of the different geometries need to be brought together by joining processes, so that the large structures can be created. And then coming to the machining processes. Machining processes work on the approach of removing the unwanted extra material. So, say this is the raw material and we want to make the component having the finer dimensions like this. Okay. So, what we will be doing? So, this is the component to be made using this stock or raw material. So, what we will be doing? We will be just removing all that which is extra. So, this so, this is the material that we want and the remaining things we do not want. So, all this hatched section, the material of the hatched section need to be removed, and for this purpose the material is removed with the help of suitable tools or machine tools. So, controlled motion of the workpiece and tool helps to just remove all this unwanted extra material. So, this is called removal of material. Material is removed in form of fine chips. These chips are of no use, so it is a wastage of the material. So, if we see this process is a negative in that way, in the sense that we take the stock material and unwanted extra material is taken off or it is removed, so that the desired size and shape can be achieved. Coming to the capabilities of the process is moderate in terms of the tolerance which can be achieved, and the finish is not very good. Like say finish may be vary from 2 to 50 micrometer in terms of the RA, and the tolerance is also not very good. Similarly, forming processes we can achieve really good finish for the cold forming, but not for the hot forming. So, here it is also the moderate in the sense of surface finish, and the dimensions or the tolerance, the joining is poor in terms of the control over the tolerance, and the finish we need definitely the good the post machining or the secondary processing, and the machining it offers very good finish and very close control over dimensions. So, in that way the machining is good, because it helps to achieve the close control over the dimensions, but this is a secondary process. Most of the time whatever is made by the casting, forming or even joining need to be machined, so that the desired finish and desired control over the dimensions can be achieved. I will talk about, so these are the this is the general approach which is used in case of the four major manufacturing processes. Likewise, there are other processes, heat treatment, case hardening, etc., and the semi finishing and the finishing processes. So, surface properties, improving the properties and the surface properties, both these actually work on the controlling the structure or microstructure of the material, so that the desired combination of the properties is achieved. And for this purpose, what is done, basically we follow heating, soaking, and then very controlled cooling. This is what is done in case of the heat treatment. And for the case hardening purpose, so basically try to control the microstructure of the material, so that the properties are incorporated or imparted as per the requirement. And other properties, like for the case hardening, purpose, like the surface properties, the surface whose properties need to be improved, we try to adjust, either apply heat, so that the near surface layers are, structure of the near surface layers is modified, or we introduce carbon, nitrogen, boron, aluminum, chromium, silicon. All these elements can be incorporated or introduced near the surface layers, so that the properties near the surface layers get modified. So, in this case the chemistry is modified besides the changing the structure. And third approach is development of the coating. In this case, what we do, basically the component whose surface properties need to be improved. So, these are the two categories where only surface properties are improved, while in case of the heat treatment, the bulk material properties are improved. So, for when we apply coatings, for application of the coating, the coating may be of very thin in dimensions, like say 5 to 10 micrometer, or it may be very thick, like say 200 to 600 or even 1000 micrometer. So, depending upon the hardness of the material, thickness of the coating is influenced. Softer the material, thicker can be the coating; harder the material, thinner coating need to be used. So, when these so as per the purpose, as per the requirement, either hard or the soft coatings need to be developed, so that desired functionality in the product can be achieved. So, I will conclude this presentation. Now, in this presentation I have talked about the fundamental mechanisms and the approaches which are used in the manufacturing processes, and basically in detail I have talked about the approaches used in the casting, forming, welding, and the machining or the metal removal processes. Thank you for your attention.